Hi there. Um, I'm going to talk today about a shared library that I've been developing for helping with code reuse, specifically in the Jenkins world. Um, Kevin and I have been working on ISGIS APIs for the last several months. And currently that project has 4 APIs. There's 2 foundational APIs, one that queries those foundational APIs to produce formatted code books, and finally one to take a request from the extract engine and deliver and assemble a detailed response for extract requests. So those 4 APIs, data, metadata, codebook, and extract, are all separate, and they're separate repositories, but they share a lot of the same patterns. So there's a lot of advantages to doing work for APIs in this kind of microservices way, and it's the way that we're driving our code right now. But there is one distinct disadvantage, and that is you find yourself repeating code a lot, and especially when you're dealing with building up CI/CD across multiple repos. If you're running the same pattern over and over again, you end up with really, really similar code. So I'm going to show you this. These are the 4 APIs in ISGIS. This is the Jenkins file in all 4 of them. And they're each about 100 lines long. They are almost exactly the same, but not quite. Each one does slightly different things, but effectively we're doing the same thing. These Jenkins files exist to help us with a continuous deployment framework, and this is currently where we're sitting. So I took a look at this and I thought, you know, there's got to be a better way. And Jake pointed me to some code on Jenkins about how to share a library across these. So let me just go over the goals of a CI/CD effort in ISGIS, which I think we're going to find is going to be similar for any API deployment, but these are definitely common across the 4 APIs I just described. We want to be able to have an automatic Docker container deployment after a Git commit. We want to be able to do that on the main branch, which we know is master. And we also want to be able to deploy on development branches automatically. So by doing that, you can go from check-in to a live and exercisable API in just a couple minutes. And we're generally following this pattern that the API on the main branch is called API name.dev.ipums.org. And then on dev branches, it's API name _ branch name.dev.ipums.org. Those URLs are driven by traffic, which is all part of the Jenkins file and Docker Compose ecosystem. So what we ended up building in Jenkins with Lee's help is this Jenkins multi-branch pipeline pattern. We did it for one API, and then we did it for the other 3, and they all follow these 6 steps. This is probably the same set of 6 steps that all API deployments are going to follow, and I'll get to why that's important in a little bit. Those 6 steps are, we dynamically create a .env file. The env file is the file that Docker containers use to pull in environmental variables that are critical and important for running the Docker container in the way that we want it to. Second step is to build the Docker image. The third step is to take that Docker image and push it to Artifactory. The fourth step is sending the .env file and our Docker Compose file from our repo to the host. The host in most cases here is going to be dev.ipms.org, but it doesn't have to be. Step 5, starting the Docker container on that host. And finally, step 6 is verifying the API is up and running and responding to requests as expected. We do that with a request to a given endpoint where we know that the status code response should be a certain value. And again, this is kind of what a Jenkins file looks like. This is one from the codebook API, but you can see we've got those steps that I just described are described here. Here's a step where we're building the env file. Here's a step where we're building the image. Oh, I should have added, there's a 7th step. We're running unit tests as well. Then we push the image to Artifactory. We send the env and the Docker Compose file to the host. We start the container, and then we verify that the API is fully deployed, and then we do some cleanup work. This pattern is the same across all the APIs. So this is a quick look at the shared library shared library support on Jenkins, and they've got a nice piece of documentation here that shows you more or less how to put things together. The underlying code in Jenkins is groovy, so this is pretty nice for somebody that's a Java programmer, which I am not, but I was able to sort of stumble my way through it and produce something that I think is immediately usable by everyone. What I did was I created a repo called Jenkins Pipeline Library. There's a nice README in here on how to use it. I'm going to describe that as well here. But if you go to this repo, there's background information on how to use it in your own Jenkins tasks, in your own in your own Jenkins files. The thing that you have to do, and actually you don't have to do it because it's already done, is I created this pipeline library, and then I needed to glue Jenkins to this repo, and you did that, and I did that through configuring Jenkins here. It's in the main Jenkins configuration, down a bit in the global pipeline libraries section. You'll see that I named it Jenkins Pipeline Library, which is the same name as the Git repo. We're going to be using it off of master. There is ability to change that should we ever need to, but this will default to master. It's also, you can point to a specific version of the Jenkins Pipeline Library should you want to, and you can do that right in your Jenkins file. But if you don't explicitly say a version, it will default to master branch top of tree. But once I glued that together there by putting in the Git repo URL here with our GitHub credentials and saved it, that was done. Jenkins was just ready to go. So a little background on the guts of what's going on in Pipeline Library. There's 2 things that I built in the Pipeline Library. One of them is a library that's importable into Groovy code, and I called that deploy utils. And what deploy utils does is define a bunch of static methods that do the things that I've been describing. Creating an env file, SCPing the Docker Compose and env file to the host, starting the container, running unit tests, building the Docker image, pushing it, setting environmental variables. This is a step that's really important before we do the rest of the steps. Some of these environmental variables that get written to env are dynamically decided. And then finally verifying the API with curl. So these are modular methods that can be called against this deploy utils library. You'll notice that each one of them has one passed argument, which is script. Script is the Jenkins pipeline object. Typically, at least from what I've shown you so far, a Jenkins pipeline object is defined in a Jenkins file. But in this case, actually, I'm defining the pipeline object in this method called API delivery pipeline, which is how an end developer is going to be accessing this shared library. And we'll get to that. So this API delivery pipeline file here, which resides in the vars directory, I should say, this first one is in the org ipums directory, and it identifies a namespace that's org.ipums.deployutils. That's all Java ease. But I'm supplying this this method, exposing this method to people that use the shared library called API delivery pipeline, and this is the model that produces the exact pipeline that we want. And you'll notice this is actually a defined pipeline here that defines all the steps that I showed you in the Jenkins file previously, only they're much simplified, because now at a high level, all we're doing is making calls to our deploy utils object here. So we're calling set environment vars, creating on vfile, Docker build, run unit tests, Docker push, SCP to host, start container, and verify API with curl. So this is still part of the shared library code, but it's very simple to understand. These 7 steps here are all defined in this structure, and they call the deploy utils method, which does the dirty work under the hood. And then we do the cleanup here. So this is the entire pipeline that we saw in the Jenkins file, but it's defined in this method that I'm going to expose called API delivery pipeline. So how does a developer build a Jenkins file to use this? That's what's here over here on the right. The first step is on line 1 of your Jenkins file. You import the Jenkins pipeline library. This is the name that we defined in the Jenkins config. So now we pull in Jenkins pipeline library, which has an exposed method called API delivery pipeline. API delivery pipeline has 6 required arguments: project, host, branch name, verify endpoint, verify method, and verify expected code. I'll go through those real quick. Project is just the name of your API. In the case of our IHGIS ones, it would be, for example, IHGIS_codebook_API. The host is where you want to deploy it. This might end up being dynamic. For now, in the IHGIS world, we're only deploying to dev right now, so I've just hard-coded this to be dev.ipums.org. Branch name is one that we're going to pull from the environment that Jenkins is running in. So the branch name is available there as env.branchname. We want to send this as an argument, though, because we want this to eventually get into the .env file that's sent to dev.ipums.org. And then these last 3 here are all about the verifying the API step, this verify API with curl step. And all you have to do is define the endpoint you want to check, define the method. This is typically get or post, and what code you expect. 200 is a typical successful response. In some cases, we actually put 403 or not, yeah, 503, 403, 403 in here, when we're purposefully putting an endpoint that should respond with an error. It depends on your exact use case, but there are times when if these endpoints are very data dependent, you might want to fudge an endpoint that causes an error rather than put an endpoint here that has specific data that might change from underneath you and break your test. But this is it. This is all there is to it on the Jenkins file side. And I'm just going to show you this. I'm going to go back to these APIs. These are the Jenkins files before we implemented the shared library. And I'm just going to go through and show you what they now look like on master. There's 1, there's 2, there's 3, and there's 4. So we've gone from 100-line Jenkins files that share 98% of their code to 15 at the most lines of Jenkins file, of which a lot's the same, but all you have to do that's different across these is define your variables. You can also send extra variables, like for example, in this codebook API, I'm sending a key value pair metadata API server. And I'm doing that because I want that to end up in the env file because it's used by the application. And over here in the metadata API, we're putting a couple more in there, db and dbdir. Over here in the data API, current data root is another environment variable. So you'll see that you can tweak these, sending extra key value pairs to do what you need to do. But you do need those first 6: project host, branch name, verify endpoint, verify method, verify expected code. But in the end, what we've solved is a problem where we are repeating ourselves like crazy. And now these are both easy to maintain with very little repeated code. My hope is that this API delivery pipeline can be a general solution for APIs outside of ISGIS. If they're not, I would love to figure out a way that we can better deliver generic solutions through this shared library to enable us to deploy these microservices faster, easier, and in a more repeatable fashion. And with that, I will stop talking.